In this lesson, we want to find the capacitance of a spherical capacitor. Again, this is very easy, very simple. A spherical capacitor has two spherical conductors, concentric spherical conductors. Let us say the radius of the inner sphere is A and outer sphere is B. Now we want to find the capacitance of this spherical capacitor. There are four simple steps. The first step is to assume a charge Q on the plates. Even though these are spherical, we can call them plates. Now, let's assume that the charge on this inner spherical conductor is plus Q and the charge on the outer spherical conductor is minus Q. So, first step is done. Next step is to find the electric field. Here electric field will be variable, we'll find that. And then we have to find the potential difference between these plates. And once we get that, capacitance is simply Q by V. Q equal to CV, so C equal to Q by V. So now we need to find electric field. So let us try to find the electric field at a distance r from the center. To find the electric field, we'll draw a symmetric Gaussian surface. So here the Gaussian surface will be spherical, a sphere of radius r, a concentric spherical surface. So this is our Gaussian surface. Now, at every point on the Gaussian surface, electric field will be radially outwards, and the area vector dA vector will also be radially outwards. So at every point E vector and dA vector are parallel. The second symmetry argument is, since this is a symmetric Gaussian surface, all points are the same distance r from the center. So therefore it is very easy to understand electric field will have the same magnitude at every point on the Gaussian surface. So therefore the electric flux through this Gaussian surface, which is given by integration of E vector dot dA vector over the closed surface, this simply becomes E into A. And this electric flux is charge enclosed by epsilon naught, Gauss law. Right? The flux of the electric field through a closed surface is charge enclosed by epsilon naught. Flux is E into A, so E into A. The charge enclosed by this Gaussian surface is this charge Q. So we get Q here by epsilon naught. And therefore electric field becomes Q by A epsilon naught. A is the surface area of the Gaussian surface. And that surface area, since it's spherical, will be 4 pi r square. So this will be Q by 4 pi r square into epsilon naught. And this is something you're already familiar with. E is becoming 1 by 4 pi epsilon naught Q by r square. So this spherical surface, the inner sphere, behaves like a point charge on the center as far as outside points are concerned. So electric field will be 1 by 4 pi epsilon naught Q by r square. That we can get also from the shell theorem. Once we have got electric field, to find the potential difference we have to integrate E dr from A to B. This integration will give us the potential difference between the plates. Here E is variable. E is proportional to 1 by r square. So we get Q by 4 pi epsilon naught, these are constants. Integration of 1 by r square dr from A to B. And integration of 1 by r square dr is simply minus 1 by r. We can memorize that. Otherwise, this is r to the power minus 2. In integration, power increases by 1 and we divide by the new power. So we get minus 1 by r. When we put this upper limit b, we'll get minus 1 by b. When you put the lower limit a, you'll get minus 1 by a. So this will finally give us Q by 4 pi epsilon naught 1 by a minus 1 by b, because of the minus sign 1 by a has come first. And this, if we simplify, we get Q by 4 pi epsilon naught b minus a divided by ab. So this v has now become Q by 4 pi epsilon naught b minus a divided by ab. This is v, and once we have found v, we can find capacitance. Capacitance is Q by v. So Q will cancel and this will become 4 pi epsilon naught AB divided by B minus A. This is the capacitance of a spherical capacitor, 4 pi epsilon naught AB by B minus A. Now this equation we can simplify or we can modify, okay, and write this as C equal to 4 pi epsilon naught, we divide numerator and denominator by B, 4 pi epsilon naught A divided by 1 minus B by A by B. We have divided the numerator and denominator by B. So here if B tends to infinity, then we get C as 4 pi epsilon naught A, and this is the capacitance of an isolated spherical conductor. So this isolated spherical conductor, we can assume that the other plate is of infinite radius, and we get C equal to 4 pi epsilon naught A. So the capacitance of a spherical capacitor is 4 pi epsilon naught AB divided by B minus A.